Purpose of this video is for you to be able to use feedback, and in this case, percent error, to make decisions or predictions. Start with an analogy towards basketball or any sort of practice, a comparison. After the first day of practice, the coach quickly realizes the team's got a lot of work to do. After practice pi, he also figures out they're pretty bad. And he just tells them they didn't play well today. And in 46 or 45, he tells them that they're okay, they're getting better. And progress is still going slow, because when he says they're one step at a time, he really means that they're still not that good, but they're getting better. Now, he also tells them that there's a game tomorrow. And he's thinking if they're going to win or not. And he thinks back to how they did bad, terrible, okay, and they were far from good. So he really thinks they're going to get killed. So he's using the using the feedback that he's seen from their practice to make a prediction. Of course, he doesn't say that to them. He's thinking that. And he tells them to be here at 6 o'clock. So the feedback he gets is all these different practices, data, and then he uses that to make the prediction that they're going to get crushed. You could compare this to archery as well. This blue here is where your arrows fell on the first day. The second day, you see you were a lot more precise in how you grouped the arrows. And the third day, your precision went and your accuracy went down. And on the fourth day, the same thing happened. So we had one really good day, 2 or 3 not so good days, and one day maybe a little bit not that good. So that's 4 of those is those are the 4 feedback we're getting. And that's going to give us this kind of performance indicator. We're going to probably have not the great precision, but a moderate, an okay accuracy as well. This applies to a liquid. Let's say that somebody wanted to measure a liquid, or excuse me, not measure a liquid, but identify a liquid. Dr. Square decides that he's going to measure the liquid's boiling point. The first thing he does to do this is he measures the boiling points of 3 standards, liquids that he knows what the boiling point is, or knows where he can look to find the boiling point. So he measures all 3 liquids' boiling points, and this is what he measures them to be, standards, and finds what their accepted boiling points are. He's going to compare them to compare his value, the experimental value, and the accepted value to calculate a percent error. And that percent error is going to tell him how good he was at measuring the standard values, or these standard values. So in the first one, he hit it spot on. He had 0%. With rubbing alcohol, he had 1.2%, which is also really low percent error. And for liquid oxygen, he had even lower than rubbing alcohol, 0.5, but not as good as water. So that means he did really well in measuring the values of standards. The boiling point of the unknown liquid, whatever he gets, he can believe in it. He got really good standard PEs with the standard, so he can trust his data. He can trust the fact that when he measured the unknown to be 355, he can trust that that's probably really actual boiling point of the liquid, not the actual boiling point, but the accepted boiling point. He looks up in his book and he finds mercury. Therefore, he's going to say, hey, this is mercury. Now, in this scenario, the low percent errors is the feedback we're getting from our standards, and that means we're making from our data we can make good predictions and we can trust them. We can trust whatever number we're getting based upon our data. And with high PEs, they make poor predictions and you cannot trust those predictions that they make.